This is 4.2, solving a system of equations by substitution. The last lesson we solved a system of equations by graphing. Remember, a system is more than one equation, and typically we do two equations. Sometimes we can do three or even more, but we want to find the point that they cross at when we graph. So even this example that I have here, 4.2. The very first thing I want to find the point of intersection by graphing, and that's what I did the last lesson. So I want you to focus on, I have to find the x and I have to find the y. Now this lesson, we're not doing it by graphing. You still could do it by graphing, but that's not what the directions are going to ask us on this. It's going to ask us to solve it without graphing. We're going to do it by substitution. But again, keep in mind, I'm looking for a point because I'm trying to find the point that the lines cross at, but I'm going to actually do it on this lesson. I'm going to actually do it without actually graphing. Now, let me review what substitution is. Way back at the beginning, not even this year, even the previous years, you had to evaluate problems like this, and you literally substituted, x is 4, so you substituted the x for the value 4. And then you just worked it out. And that's what substitution is. You substitute the value. Well, the same thing with an XY chart. You literally substitute -3 in right where the x is right there. And then you evaluate it. And then you substitute 0 in and you evaluate it. And then you substitute 1 in and then you evaluate it. So this actually is 3 separate evaluating problems, and then you literally find that y, you find that y, you find that y, and then you can graph those points. But that's what evaluating is or substituting things in. You substitute things in, and then you work it out to get to your answer. So that's what we're going to do here. We're going to take one of these equations, and we're not just substituting like this previous problem. We just substituted a number in, like x equals 4. We're not going to just substitute a number because we don't have a number. We have two equations. So what we're going to do is look at one of the equations, and one of the equations is already made out for us. It already tells us this is what y equals. Y equals 6x plus 7. So if y equals that, we're going to literally substitute the y in. So instead of writing this y, we're going to substitute this in. We're going to replace this y with all of that, because all of this is what y actually equals. So here we have 3x minus 8 times y equals 4. But remember, the y is 6x plus 7. So again, this y is all of this, because that's what it says. It says y equals all of that. And then what you're going to do is just solve this equation. We're going to use the distributive property. That's -8 times 6. That's -48x. And then -8 times 7 is -56. 3x minus 48 is -45. I'm going to add 56 to both sides. Divide both sides by -45, and then reduce. Notice those, there's a 5 goes into them, but also a 15. A 15 goes into each one of those, so we're going to get -4/3 when we reduce that. So the x part of my point is -4/3. And then what I need to do, remember, I'm trying to find a point, so don't stop the problem right now. Don't say, hey, I solved for x. Remember, on this problem, I'm trying to solve for x and a y because I want to find the point. If I did graph these problems, they're going to cross at a certain point. So what I need to do now is I need to substitute. I know x is -4/3. So I'm going to substitute that back in to one of the two equations at the very beginning, one of the two equations, whichever looks the easiest. Now, typically, this one's going to be a lot easier because we're solving for y. So 6 times the x plus 7. We're just going to substitute this x right there. We're going to substitute that in. right there, so negative 4/3. And then we're going to work that problem out to find the y. This is going to give me negative 8. When I multiply 6 times negative 4/3, I'm going to get 8, negative 8. And then this is going to give me negative 1. So y is negative 1. Now, one way to check this is you could simply graph these and make sure that it actually crosses there. The first equation is y equals 6x plus 7. So if you type that in, 6x plus 7, and again, this is one way you can check the problem. And then the second equation, this has to be solved for y equals mx plus b. Remember, to plug it into the calculator, it has to be y equals mx plus b. So if we solve this for y equals mx plus b, this is going to end up being y equals 3/8x minus 2. And so if I type that in, 3/8x minus 2, and I'm going to graph, and I want to find out where it crosses at. And notice, to check my answer, I need to see if that is correct, where the point of intersection is. And so remember how I showed you on the last lesson, I'm going to find the point of intersection. Go to where it looks like the point of intersection is, and basically hit enter, enter, enter. And so negative 1.6, and then negative 1. And I just noticed, because it's not the same answer, this is a good lesson. I didn't mean to make a mistake, but I did. Notice the answer that the calculator says is not the answer that I came up with. So it's like, well, wait a minute, where did I make a mistake? And this is why it's good to double check. And it just simply came when I solved for y equals mx plus b, I solved for it in my head, and that's the mistake that I made. So this actually is going to be 1/2 right here. So if I go back and change this to 1/2, now I push graph. All right, so now this looks a lot closer to my point of intersection, and I'm going to double check it. Do the point of intersection, just move it to the point of intersection, press enter, 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 and I get exactly what I have. That's exactly the answer I have, the point of intersection, and I did that by the substitution method. All right, so again, if I did this again, I'm doing this by substitution, and I'm not doing it by graphing, although we could check it by graphing. You can check this by graphing. So what I'm going to do here is I'm going to substitute. Notice this one actually starts off with, this is what x equals. X equals this. So we're going to actually substitute that in right there. Because all of this is what x equals. So we're going to substitute that in to the next equation. So we're going to substitute y plus 6 for the x. And then you still have plus y equals 10. And then we're just going to solve that equation. So 2y plus 6 equals 10, minus 6 from both sides. Divide both sides by 2, and y equals 2. And again, don't stop working the problem. Remember, keep in mind what we're trying to find. We're trying to find a point that if I graph this first equation, if I graph the second equation, they would cross at a certain point. And so the y part of that point is 2. And then if I substitute 2 in for y, notice I'm going to get 8 for x. So 8, 2 is the answer. And again, you could graph both of these and see if that's true. But I would encourage you a little bit quicker. Sometimes it's quicker just to check it. So if x is 8, so put an 8 right there, and y is 2, does 8 plus 2 equals 10? Yes. But remember, it has to work on both equations. So if x is 8 and y is 2, does it work on that equation? Yes, it does. So that's what you're trying to find. Does this point work in both equations? It has to work in both equations. Because remember, if you graph one line, you graph the other, you're trying to find out the point of intersection. There is one point that they both cross at, and that's the point of intersection that we're trying to find. So let's look at another illustration here. Here I have y equals 2x minus 1. And again, notice it gives me this is what y equals, so I'm going to substitute that in where y equals. And so 2x plus 3y equals negative 7. And I'm going to substitute all of this in. 2x minus 1. So I'm going to use the distributive property. All right, so I'm going to get negative 1/2. Remember, keep in mind, you have to find a point, which is your x and your y. So the x part of the point is negative 1/2, and then I need to substitute that back in. Again, right back here is the easiest spot. You can plug it back into either one of the beginning equations, but this one's easier. And again, if you substituted, this is the point of intersection. If I graph the first line, if I graph the second line, that's the point of intersection. And again, you can always check this by substituting this x in and this y in to both equations to see if it actually works. So, and you can easily do that or graph them either way to check your answer. So let's look at some special cases. What if, I have these two equations and I started working these problems and I'm going to get down to a certain point, and it's something I want you to pay attention to. All right, I went ahead and worked the first couple steps of this problem. I did the same routine as usual. I basically just took this right here. This is what y equals, and I substituted it in right there. And then I worked it out, and I want you to see what happens. So I just used the distributive property, and notice I got 6x minus 6x. So the x's actually cross out, and I end up with a true statement. Negative 2 does equal negative 2. Well, obviously it's a true statement, and what does this mean? Remember, if I graph that line, if I graph this line, notice I get a true statement. There are no x's, so I can't actually say x equals this, y equals this. So on this scenario, there are an infinite amount of solutions. And remember, we talked about this on the last lesson. So if you actually solve, this is already y equals mx plus b, this first equation. So if you actually solve for y equals mx plus b on this, you're actually going to get y equals 3x plus 1. And notice it's actually the same equation as this first one. And so if it's the same equation, then there's an infinite amount of solutions. So you could simply just solve for y equals mx plus b on both equations, and then you can see that it's an infinite amount of solutions. So if you did graph that, literally, if you graph this second line, you graph this first line, they're the same exact line. That means every single point is going to be every single point of the other line. So it's an infinite amount of solutions. Now let's look at this second equation, the second example. Here, again, I started solving it. Same thing, I substituted this into the y of the other equation, and then I started solving it, and notice the x's cross out again, but notice I get something like this. It's not a true statement. So this actually is no solution. And remember what we're trying to find. We're trying to find a point of intersection. If I graph this line, if I graph that line, what point would be in common? Well, the only way it could be no solution, and again, I showed you this to you on the last lesson. The only way this can happen, that there's no solution, is if these lines are parallel. And again, if you solve, this first one is already y equals mx plus b. If you solve for y equals mx plus b on this one, you're going to get y equals 5x plus 4. So notice they have the same slope. So this has 5x minus 4, this has 5x plus 4, and parallel lines have the same slope. They will never, ever cross. That means there is no point of intersection on that one. And again, that's our lesson about solving a system of equations by substitution.